Okay, everybody, so I'm going to start with a little review of what you should have learned from yesterday. But get these notes that look like this. They should be posted in the Schoology Drive for today. But we'll use those in just a second. First off, let's say you had this graph of 1 over x plus 9. By now, you're supposed to know a few parent graphs. If you haven't already, you should make a little list of them. Y equals x squared. That's a U shape. Looks like this. Y equals the square root of x. And that is a little ramp that goes like that and heads forever in that direction, but stops right there because you can't put in negative numbers. This one touched at 0, 0, by the way. Sorry, my accuracy's off a little bit. And then there's this one, y equals 1 over x. That's one of those parent functions you should know. 1 over x looks like this. And if you're confused about that one, go back to the chart. You can always make an XY chart for it. You stick in 1 and you get 1. You stick in 2 and you get y equals 1/2. And that would be places like this and this and this. And it's going to get infinitely close to the origin, but it won't touch it. So it has asymptotes there and there. This is the x-axis, but the asymptote that runs across there is called y equals 0. It's easy to get those confused. So many little things you have to know for this. That's why I'm making this video for you. This one's the y-axis, and so that dotted line that's the asymptote, it's running through the y-axis, is x equals 0. All right, now this one is the one I mentioned, and you have to know that it starts looking like that. And then you have to know that this thing moves it up 9. All right, so if I made a new picture of it, I would have to go, okay, well that if I go up 9, it used to go, there used to be an asymptote at 0. Now there'd be an asymptote at 9. Do you see how that whole thing got moved up 9? All right, and then we asked you yesterday to get the domain and range of them. I'm starting with a really tough one here because the domain, it seems like it goes forever in both directions. Remember, this is the x's. The x's seem like they go forever in both directions, but what is the one number they can't hit? As far as x goes, remember, domain's about the x values. What's the one number they can't hit? 0. So it goes from negative infinity until it hits 0, and then it doesn't work. And then it goes from 0 to infinity. I type I and F, like I write it out in letters because if you're doing a Schoology quiz, for example, you'd have to use I and F because there's no little sideways 8, for infinity. The range is also similar in that it seems like it almost goes forever up and down, but in this case, because our asymptote is moved up here at 9, because of that 9 right there, the whole thing got moved up. Then it goes from negative infinity until 9, union 9 to infinity. Now, if you've taken good notes on this, I'm going to leave it up there for another few seconds, and if the sub would pause this, that would be great. So people can take good notes on that. That's one of the toughest ones. Then we'll do an easy one just to make sure that you really got this. Okay, so here's an easier one. Let's say that we had y equals x minus 3 squared plus 2. If you sketch this thing, it's going to be so much easier to tell a domain and range of this. I mean, so much easier. So if I sketch that, I can say that this is a parabola because it's an x squared, but it's been moved to the right 3 and up 2. If you haven't been diligent about taking notes on this, do it now. right 3 and up 2. And if their signs had been reversed, then they would have been going the other way. All right, so this parabola is right 3 and up 2, so I'm going to say that that's right 3 and up 2. So there is my parabola that's been shifted right 3 and up 2. Now what's its domain and range? Well, domain goes forever this way and forever that way, and there isn't any asymptote that stops it, and so it just goes forever. So you'd say negative infinity to infinity. And the range is how low to how high. And how low does this one go? It goes to 2. And how high does it go? Infinity. And then it needs a bracket on the 2 because it touches right there. All right. No easy stuff. All right, now we're going to get into the actual notes for today. And the main thing is we are trying to use function notation to describe a translation. What that really means is like this. If I say f of x, that's a function, right? If I say f of x plus 1 minus 3, that means it's been moved 1 to the left and down 3. That's how you do it with function notation. You just say f of x and then do your changes on the inside, horizontal on the inside, and the outside, vertical on the outside. All right, so next, perform a translation on an unfamiliar function. That really is talking about if I make a little weird sketch like this, that if I wanted to take and say that's f of x, you don't know what the equation is and you don't have to, but it goes forever in that direction, but it's got like a little dot on this end. Okay, so there's my function. What if I said I wanted to move it down 3? Would you get that this spot, for example, just needs to move down 3, and so do all the other spots? And so now, there, I've moved that function down 3. And this would be f of x, except it's been moved down 3, right? Minus 3. Next, they want you to be able to write an equation for a translation on a function that's been translated once before. So in other words, let's say we have a function that has already been moved like this, and then they say, take that one, which has already been moved left 2 and up 3, and then move it right 1 and down 1. I hope you're smart enough to go, okay, if I'm going to move this to the right 1, that's like minus 1. And so I'm going to put that with the plus 2, and together that'll make f of 2 and the minus 1 makes x plus 1. And the down 1, well, that's like going down 1 is like a minus 1 here. And so this 3 tells me I should go down 1 from there, so plus 2. And here's my new function then. That was the blue one, and then it moved right 1 and down 1, and now it's this one I just highlighted right here. All right, now there's just a super quick overview of what I'm going to try to teach you today, and now we'll go on. Everybody look at this. You need to remember how to make one function eat another function. In honors level math, you can't afford to forget stuff that we taught you earlier. So we did teach this. You had a whole day on making one function eat another function. You're supposed to be good at that by now. So now I take the f function, which is right here, and I put an empty parenthesis where the x was, and I make it eat a g function, which is right there. So that goes here. And do you really need a parenthesis inside those absolute values? No, you don't. And there you go. And doesn't that suspiciously look like one of those problems we just did where we take the absolute value and move it left 2 and down 5? See how that worked? Okay. Now, on this one, it's a little more complicated. We want to put x minus 1 into the f function. Always do math one step at a time. So I'm going to take the x minus 1, and I'm going to drop it in to the f function, which is right here. So I'm going to take this function and write it out with the parenthesis where the x was. And I'm going to drop in an x minus 1. Because it said right here that we were doing f of x minus 1. So I put that x minus 1 into the f function, and this is what I got. And then this 2 plus, well, I could just put a 2 plus right here. But it probably would make more sense to put the plus 2 here, because then I can put it with that minus 5. So my final answer on this one, if I get rid of the double grouping symbols. There you go. Okay. How could we describe these in terms of that? Well, it's like the parent function except moved left 2 and down 5. And what's this one like? Right 1 and down 3. All right. What would the graphs look like? Well, frankly, it's going to take too long to do it. And this lesson would last forever. So I'm going to put an XY chart here and just remind you, if you needed to graph this, you could either take a V shape like this and move it 2 to the left and down 5, which is like here-ish. Or you could actually make an XY chart and make it really accurate by going, okay, I'm going to stick in some numbers. How about -2? Because that makes this part 0. And that'd be -5. -2, -5. All right. And then that was a V shape, shifted left 2 and down 5. So I can just make it a V shape from there. All right, and it has arrows on the ends. Okay, then this one is this one, and that'd just be a V shape that's been moved 1 to the right and down 3. All right, next page. So on this one, I'd like you to do it. We'll pause for a second while you work on this problem. And then once you've had time to try this one, then we'll come back together and I'll explain how to do it. Okay, so first off, it says find g of f of x. That means the g function, this guy, is going to eat that. So I take my x minus 3. Notice I replaced the x with a parenthesis. And then I put in this. Square root of x plus 1. All right, so there's my function. Square root of x plus 1, keep it all under the root, minus 3 outside the root. There's my function. And now if I had to describe that, oh, that's easy. I'd say it was 1 to the left, down 3. And if I was going to graph it, oh, always, in my opinion, make an XY chart. Could you memorize the parent points of the square root graph and then have to move them every time, all these different places, like 1 to the left and down 3? You could, but in my opinion, so much easier to just pick some points logically, like -1 works really well, because then you have 0 minus 3 is -3. And just find a few more points. So I'm going to do -1, -1, 2, 3. And then I'm going to go with putting in 0, because that makes this 0 plus 1, which is 1. Square root of 1 is 1. 1 minus 3 is -2. 0, -2. Oh, I missed it. 0, -2. And look, it's basically like that. And I know I went too fast. I'll do one more point, fine. So let's say I put in 3. Because 3 plus 1 is 4. Square root of 4 is 2. 2 minus 3 is negative 1. So 3, 2, 3. Look at that, I even hit it. I got lucky. Okay, so there is my square root graph. I describe it as a ramp, but it's been moved. Right, now this is more practice of the same exact thing. And again, you just stick in that into the f function, and then you would graph it. All right, to graph, you just make an xy chart. So I'll show you real quick. I would take this function, and I'm going to stick an x plus 1 in it. So instead of the x squared, empty spot squared, feed it an x plus 1. And now I know the equation is y equals x plus 1 squared. That is a parabola shifted 1 to the left. Should be easy peasy. All right, moving on to this page. So here you'd make the f function eat the g function. You'd figure out what the new equation was and graph it. You can always make an xy chart. Choose key numbers off your to put into your function. If you want to see those, we have completed notes that you can look through if you'd like for today. And this is one where you've got a graph that's already been moved once. This one's been moved 2 to the, somebody say it, right. And that means it's been moved down 1. Very good, okay. Now they want you to take that and move it left 3 and up 4. No, we're not talking about a new function where you just go, my plus 3 would be left 3 and up 4 is plus 4. No, you take and add that to the numbers you already had. And if you wanted to go left 3, then in here you'd go add 3 to it. That's like going left 3. And up 4, that's like adding 4 right there. So then my new answer for this, after you take the moved function and move it again, now you're at x plus 1 and plus 3. Okay. So if I wanted to move this one left 1 and down 2, put the appropriate things here and get a final answer. I'm going to have you pause for just a second so kids have time to finish this up. And in this case, this would be x plus 5 to the third. That's the x to the third function. That's not a parabola. I didn't mention this one before, but the x to the third function looks kind of like this. That's the cubic function. That's the parent function. Okay, so now this is going to be x plus 5 to the third, and then the minus 3 and the minus 2 go together, and that makes minus 5. So all said and done, the function will, first it moved here and here, then it also moved an extra this, and this is its final answer. All right, so what if they give you a weird looking shape? And then they say, I'd like you to take this weird looking shape and do this to it. Like this is your starting function, and then you're supposed to do this to it. Well, then you take all those key points, this point and this point and this point and this point and this point, all these key points, and then you move them, what it says, 2 to the right and down 4. So I'm going to do it in a bright blue here. 2 to the right, down 4. That's where that one went. This point now, 2 to the right, down 4, right at the origin. Now this point, 2 to the right, down 4. Now this point, 2 to the right, down 4. And last but not least, this one, 2 to the right, down 4. Doot, 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 doot. There we go. The whole thing, the purple one, has been moved. 2 to the right and down 4. All right. So take this weird shape and actually move it 2 to the right and down 3. And then you can check it against the completed solutions. Now, what if we say, this is what we did. We took the shape and we did that to it. It's been moved, clearly, but which way has it been moved? Well, I think it's been moved to the, well, if it depends. Which one was the original one? It says right here that the blue one was f of x. That means the purple one is the one that got moved. So which way did it get moved and how far was it? Always start with f of x, but then leave yourself some room to say which way it moved. Looks to me like it moved 1, 2, 3 to the right, and down 1, 2, 3, 4, 5. 3 to the right, and down 5. There's my equation. Okay, now how do circles fit into this translation stuff? Well, the equation for a circle is x squared plus y squared equals r squared. And hey, you signed up for honors, not me. Pay attention. You can do this. And if this circle hasn't been moved, then I don't have any changes to my x or my y. But its radius is big. How do you... there's supposed to be a radius right there. Well, the radius, I can tell by looking here that it's 7. The radius is 7. So instead of the r, I can put a 7. All right. Now, what if I actually moved the circle? And you'd have to figure out where the new center is of the circle. Let's say I think that's the circle's center. Then which way did it move? Did it change x-wise? Or did it change y-wise? Or was the radius different? All right, well, to me, it looks like the radius is 7 still, because I added it up and it went from 10 to 4, which is 14 total. Okay, from negative 10 all the way to 4. So again, 14 total. So half of that for the radius would be 7, so this is 7 squared. And then this whole thing got moved. I think it's 3 to the left. Don't hate me if I'm reading that wrong, but I think that's 3 to the left. There. It didn't move up or down, so we don't have to put anything in here. But then there's your equation for the circle. That's got a radius of 7 and has been moved a little bit. I hope that makes sense too. All right, so what was this telling you about this circle? Not moved at all in the horizontal direction. In the vertical direction, it's so common for kids to go, we always trust the y, but the y normally isn't on the inside of a parenthesis, so we don't trust this. So it seems like it's moving down, it's actually moving up 2. Remember that rule if you're inside a parentheses, like this is, with a squared on it, that stuff does the opposite of what you would think. Okay, so it's an up-down thing. And it seems like it's down 2, actually up 2. All right, and if that's a 49, they're just being tricky. That's like 7 squared, right? So it's got a radius of 7, and it's been moved. Seems like down 2, actually up 2. There's your center. Okay, if you had to graph this, your best friend in graphing comes in, the XY chart. You could make a bunch of points, and guess what? They would form a circle. But I have to admit, in this case, I would say draw a circle with a radius of not 16. Think about it. What's the radius going to be? 4. Okay, so if the radius is 4, make a circle with radius 4 that's been moved 1 to the right, and that seems like up 3. It's actually down 3. there's your center of your circle. 1 to the right, down 3. And it's got a radius of 4, so I can go out 4 in each direction. And then I can, probably going to be off a little bit, but I need to be done because this video is running long. So there's my circle. It's been moved 1 to the right, and seems like up 3, actually down 3. And again, an XY chart could be done. You'd stick in any number you want for X, like let's say 1. And then this part would disappear. And then you'd have this equation to solve. It'd be a bit of a pain in the butt, but you could figure out, oh, this has to be 4 squared to be 16. So then you could go, y must be 1. 1, 1. Look at that. It's on my circle. Okay. So you made it, and you have homework. I know this isn't perfect, but it's better than no video at all. So I did my best for you, and your homework is that worksheet. Feel free to look at the key, and that's all I got for you for today.